Hi, everybody. Professor Monty here, and let's do some examples in elasticity. So elasticity, we're going to write it as E of P. The formula we have is negative P times D prime of P over D of P. D of P is the demand function, E of P elasticity, P the price. Now, I have another video that I'll link at the end of this video where I talk more theoretically about where elasticity comes from, what it means, and we build up to it. But there's my formula, and what it refers to, E of P, so elasticity, it's the percent change in quantity over the percent change in price. So that's the basic idea. But what we're looking for is we say, hey, when I change the price a little bit, what's going to happen to the quantity demanded? Okay, the quantity demanded is this demand function D of P. So let's do an example to see how this works, and then we'll interpret the answer. Okay, so we have the formula. Let's go ahead, and we're just going to do 200 minus 5x is the demand function. So we'll keep it easy. 200 minus 5p, excuse me. All right, so there's my demand function. So if I want to do elasticity, I'm going to do this. So E of P, negative P, times the derivative of the demand function. Well, the derivative of 200 minus 5p is just negative 5. Over the original function, D of P, 200 minus 5p. Okay, so we can go from there, multiply these together, we get 5p, the negatives cancel out. Down on the bottom, 200 minus 5p. And then usually they want this simplified, so we'll divide top and bottom by 5. So everything gets divided by 5. So 5 is going to go in there once, it's going to go in here 40 times. It's going to go in there once, so I just have 40 minus 1p. So my function, E of P, becomes P divided by 40 minus P. That's my elasticity of my function. And so let's plug in a value and see what's going on. So let's say, for instance, we want to find the elasticity at a price of $25. So let's say let P equal $25. So E of 25 is going to be 25 over 40 minus 25. Well, 25 over 15. We can divide those by 5, so we get 5/3. As a decimal, it's about 1.67, we'll say approximately. Let's talk about what that means. Now, if we think of that as a fraction, so I'm going to box this, but if we think about it this way, so kind of the slope idea, because remember, what's elasticity? It's the percent change in quantity over the percent change in price. So what this is saying is, if we increase price, say 1%, then quantity, now remember, from economics, we learned that price and quantity go in opposite directions. You increase the price, decrease the quantity demanded, decrease the price, increase the quantity demanded. So these always go in opposite directions. So if we increase the price 1%, the quantity is going to decrease by 1.67%. So the number does really stand for something. It's that percent change in quantity over percent change in price. Well, if I increase the price a little bit, but the quantity demanded decreases even more, I'm going to make less revenue. Well, here's what we usually look at. If E of P is, in this case, greater than 1, we call that elastic. And if we want to maximize revenue, I don't want to increase the price because the quantity demanded decreases even more than the increase in price. So if it's elastic, I want to decrease the price. Because think, if I decrease the price 1%, the quantity demanded is going to increase 1.67%. Bigger bang for my dollar. If E of P is less than 1, we call that inelastic. And so maybe that 1 wasn't there, it's just 0.67. Well, if I increase the price 1%, quantity demanded only goes down 0.67. That's a good deal for me. In that case, I want to increase the price because the fewer units I'll sell won't be as big of a percentage, so I'll make more revenue. So I want to increase the price. And again, that's to maximize revenue. And then if E of P is equal to 1, we call that unit elastic. And that's where we have maximum revenue. So that's the idea. So if you like this, if you want to see more theory behind this, go ahead and click on that linked video I have. I'm also going to put a link there to my playlist of all my calculus videos in case you want to see some more. And plus, as always, I'll have a link there to click to subscribe to my channel. So if you like these, click the like button, subscribe to my channel. You'll be able to see lots of calculus videos. I even have some statistics and algebra videos if those help you out. But anyway, best of luck to you. So keep working because you're going to get this.